Consider a particle moving in simple harmonic motion according to the equation x is equals to 2 cos 50 pi t plus tan inverse of 0.75. Particle comes to rest for the first time. When does the acceleration have its maximum magnitude for the first time, and when does the particle come to rest for the second time? Alright, now in the first case we have to calculate the time at which particle comes to rest for the first time. Now the particle is coming to rest, that means the velocity has to be 0 at that moment. So I know x is equals to 2 cos 50 pi t plus tan inverse of 0.75. Alright, so just differentiate this equation to calculate the velocity. That comes out to be 2 into 50 pi t into minus of sine 50 pi t plus tan inverse of 0.75. This is a 50 pi. Alright, now this is the velocity. Now I want this velocity to be 0 for the first time. So velocity is to be 0. Then I can write sine of 50 pi t plus tan inverse of 0.75 has to be equal to 0. So I can write 50 pi t plus tan inverse of 0.75 is equals to pi. Now if I calculate the value of tan inverse of 0.75, it come out to be 0.643. The value of pi is 3.14. So just solve this equation for the value of t. You get the value of t as 1.6 into 10 to the power minus 2 seconds. This is my answer for the first part. Okay, now in third part I have to calculate that when does the particle comes to rest for the second time. And if the particle is coming to rest for the second time, then this condition will occur after the particle covers a phase difference of pi again. So that first is that if a particle comes to rest at the mean position at this very instant, then after the phase of pi again, I mean after traveling to extreme position and coming back to its mean position, it will be again at rest momentarily, and this is the phase of 2 pi. So I can write from this equation, I mean this condition will always hold true because velocity has to be 0 at that moment again. So this equation will come again, that is sine of 50 pi t plus tan inverse of 0.75, that is has to be 0, but this time it has to be the 2 pi because the first instant came at a phase of pi, and again after phase of pi, when the object will come again to its mean position, the total phase will be 2 pi. Okay, so 50 pi t is equal to tan inverse of 0.75 is equal to 2 into 3.14. To solve this equation again as we did earlier, in this equation you get the value of t as 3.2 into 10 to the power minus 2 seconds. That is the answer for the third part. In second part, when does the acceleration have its maximum magnitude for the first time? Right, now I do have the velocity given by the equation this. So acceleration can be written as dv by dt. Right, so acceleration comes out to be 2 times of 50 pi whole square cos of 50 pi t plus tan inverse of 0.75. Right, now again the maximum acceleration will be equal to this. This is my a max. So a max will occur when this acceleration will be equal to a max for the first time. So I can write cos of 50 pi t plus tan inverse of 0.75 is equals to 1 for the first time. I'm sorry, this will be minus 1 because we have a minus sign in the velocity also, so it will be followed over here and it will be equal to minus 1. So for the first time the value of minus 1 will come at pi, so this will be equal to pi. So again solve this equation. This equation is same to that of this equation. So if we solve this equation, we get the same answer, that is t is equal to 1.6 into 10 to the power minus 2 seconds. That is the answer.